Hi, this is Miss Goodale, and today I'm going to be talking about solving addition and subtraction equations. To start out with, before I go over the process, I want to go over some vocabulary. First, we have expressions, and this is review from other lessons because we have previously worked on expressions. And expressions are math phrases that can have numbers, operations, and variables. So an example of an expression would be 5x plus 2. An equation, on the other hand, is very similar to an expression. It actually has expressions in it. So it is a statement that two expressions are equal. So 5x plus 2 equals 10. That is an equation. And also 5x plus 2 equals x plus 1 is an equation. They have an equal sign. So the difference between an equation and expression is that an equation has an equal sign, which is what we're more used to, and an expression does not. So you're not quite as used to the expressions until recently we've been working on those. A solution is a value of a variable or the letter, sometimes it's a symbol, that makes a statement true. We can think of it kind of as the answer. So if I figured out what letter I could put in for x to make this equal 10, then that would be a solution or an answer to that. And inverse operations is what we're going to be using a lot of today. Those are operations that cancel each other out, or they can sometimes be called opposite. Sometimes I say inverse, sometimes I say opposite. Those are operations like addition and subtraction. Multiplication and division are also inverse operations. So they are basically opposite and they actually undo each other. So if I added something and then subtracted the same thing, I would end up where I started. Okay, so let's look at an example here. And this is just a simple equation. And I want to first show you how to model it using pattern blocks and then using drawings. And then we'll get into doing the same expression or equation without the manipulatives. So the first thing I'm going to do, I'm going to use my green. It's usually called a 10, but in this case, we're just going to use it as an x. So we don't know what this is. So it's not 10, it's just an unknown number. So an unknown number plus 3 equals 10. So I use 3 of these and my x. So if I put these two together, on the other side of the line, I'm going to put my 10 blocks. And this can kind of be thought of also as a balance or a scale. And I do have some games that will help you practice that with scales. There's some that you can practice with what we call mobiles. And I will probably try to link that in this video as well. Okay, so on this, I have my 2, 4, 6, 8, 10 over here. I have my 3 and my x. Now, in order to figure out what my x equals, I have to get rid of all the ones that are on the same side as the x. So I have to get my x by itself. In order to do that, I have to take out the same amount for both sides. So I'm going to take out these two. Okay, if I take out one from this side, I also take one from the other side, and then the same thing here. So then I took out the same amount from each side. Now I'm just left with my green block, which means x. And then on the other side, they should still be equal. So I have 7. So x should equal to 7. And I'm going to show you how to model that with a drawing instead of just the blocks, because you do not always have blocks with you to work this problem. So if I were going to do this with blocks, I would make an x block, and then I would make 3 other blocks. And then on the other side, I would have 10 blocks. So that's what we started out with. And it was balance. Now to finish balancing it out, we have to cross off one here and here. So 1 on each side. They're going to cancel each other out. And again, you have your x by itself, and your answer here is 7. Okay? So I have 7 blocks left. Now, if we were going to do that problem without using the blocks, then I would use what we call inverse operations. And so in order to get rid of that 3, I have to subtract it. If I subtract it from this side, that means I have to do the same on the other side to balance it out. So I subtracted plus 3 minus 3 is going to equal 0, so you just have x by itself here. And then 10 minus 3 is 7. So we still get the same answer regardless of whether we did the picture or the actual written work. Now let's do some more examples. Let's do a plus 4 equals 35. In order to get the 4 by itself, I have to subtract it because that's the opposite of addition. So I do a plus 4 minus 4 equals 35. And then if I subtracted 4 over here, I have to subtract 4 over there. So a equals, and what is 35 minus 4? It's 31. Notice I repeated the minus 4 on each side because that's the part that I put into the problem, but I did not repeat the plus 4 because the 4 is already included in that 35. Okay, so the only thing that you need to put over here is the opposite operation with what you did on the other side. Okay, let's do one with subtraction. It kind of works the same way. And this one is kind of written a little bit different than we're used to. Usually we're used to seeing the 21 on the other side, but it still works the same. So I know that I'm going to have to add to my 6. So we have 21, b minus 6 plus 6. If I add 6 over here, I have to do plus 6 on the other side. So 21 plus 6 is equal to b minus 6 plus 6. This cancels each other out, and so I'm left with b on the right side, and 21 plus 6 is 27. So 27 equals b. And if it would help you to just flip that around and write b minus 20 or b minus 6 equals 21 instead of 21 equals b minus 6, you're still going to come up with the same answer. Okay, let's do this one. Y minus 4 1/10 is equal to 5 4/10. And so this one we have minus 4.1 or minus 4 1/10. So to get rid of this, the opposite is addition. So we add in 4 1/10. And since we added it in on this side, we add it on the other side. All right, I'm running out of time here, so I'm going to have to finish up this explanation and then let you guys go. Let me know if you have any questions. This kind of thing, I know these are simple right now, but later on you'll have to remember more steps. So just remember what you do to one side, you have to do to the other side. Please ask questions if you still have some, and stay tuned for